So the most popular deployments, I would say, for the standard single data center is, the master slave. Obviously, you have a masters and a couple of slaves. Then this is more or less something which we are going to deploy in the class control. You can use an intermediate master. This is something, well, basically, in this deployment, you have master, a couple of slaves, and at least one of those slaves is acting as a master to some other subset of slaves. This type of deployment could be handy if you have, a large number of slaves. It is because, all those slaves connecting to a master, they are, this data from the binary log needs to be transferred to slaves. So more slaves, the higher the impact on the master. Therefore, for example, instead of setting like 20-something slaves to replicating of a single master, you could do like, let's say you have a master of 5 slaves, and then each of those slaves is acting as a master to another 5 slaves. And in this way, the load will be slightly reduced on each of the masters. Of course, master-master replication and topology, ideally, active standby type of the deployment. This is because, this is a really nice way to achieve high availability. It makes easier to failover, to perform failover from the one master from the active master to the standby one. So again, this is a very common pattern. Okay, let's check our job. It just finished. So right now, as you can see, we have a cluster, we have created, we have one node controller detected as a master. So we can enter here. Okay, we don't want this. And basically we have a master node, online functioning, and we are good to proceed further. So what we could do, we can create a slave for now. But first, let's try to something else. We will deploy our load balancer. And for that, we will use MaxScale. We are going to deploy MaxScale because MaxScale has this ability of read-write split, and this is really useful. Let me check the IP. Okay, so this is. I'm going to deploy it on the cluster control host. So the read-write split for MaxScale is very useful because you can point your writes, your traffic from the application to a single port of the read-write split listener, and then MaxScale will do the magic behind it. So it will detect your topology, it will follow your topology changes, it will route the queries accordingly. So the selects will be routed to slaves, the writes, the modifications will be routed to master. So it is very, I would say, handy way of implementing this kind of change. And then this kind of load balancer. So you just set it up and it works. So it may again take a moment. So let's go back to our slide deck. So for the multi-data center deployments, as I said, there is really no limitation, so that you can also, for example, use master slave over the wide area network. You can use it, for example, let's say if one of the slaves is used as a reporting slave, and maybe you have maybe the reporting is being processed on some other location than your main data center. So to put your data closer to those tools, to those processes, you can set up your slave on some other location than the main cluster. Again, active passive. it's master active passive type of deployment. Very popular so you have two data centers. You have one primary data center where you have a master and some topology of the slaves, and then you have another backup data center with also master in a standby mode, and maybe also you have a couple of slaves there. And in this way, you are able to fail over from one data center to another in a very short period of time. And of course, last but not least, the wide area network replication for clusters. So the Galera or MySQL clusters, these are the synchronous, virtually synchronous clusters, and as such, their performance is kind of limited by latency, by the network latency. So sometimes it doesn't make sense to put, to spawn your cluster across the whole continent from coast to coast or even longer distances, because the impact is too high. The performance impact is too big. In such case, sometimes it's feasible to build two clusters on two locations and then connect them using MySQL replication, again in active standby type of deployment. Okay, let's check our MaxScale. It should finished. Yes, so the job has finished, and we can see in our Nodes tab that MaxScale has been deployed. Using a cluster control, we can check the status of our topology. So as you can see, MaxScale detected one host, 0.62, as a master, and the node is running. So for now, let's add another one. Let's add a slave to our deployment. We will include it in the load balancer, and for now maybe we don't want to use a delayed slave because it doesn't make sense if we are including the host in the load balancer. So yeah, that's it, and the process started. So in short, the MySQL will be installed on this node, and then cluster control will use extra backup to provision this node from the master, and the replication will be set up. So again, this may take a moment. So let's go back to our slides. And what you can see here is a couple of schemas how the topology may look like. And as I said, it is really it could be either single or multi data centers. So we have master slave. It can be either located in one single data center, but we can imagine that the master and two slaves are located in one DC, and then this slave is replicating over the wide area network in some other place. Intermediate master, as I said, we have master, couple of slaves, and one of those slaves is acting as a master to another set of slaves. And again, it can be located in one single data center, but it can be located in, for example, two data centers, master and two slaves, in one DC, intermediate, master, and another two slaves in another DC. Master active standby. Again, we have active master configured in a master application with a standby master. Both of them have some kind of slaves connected. If primary master fails, the standby master takes over the work. And again, this could be in a single data center. They can be located in separate data centers. And two synchronous clusters connected over the wide area network. Again, we can imagine having a Galera cluster in both locations, both data centers, and they're replicating in active standby mode. The other cluster is acting as a backup. So this is, really, these are just examples, of course, because there are numerous ways you can deploy MySQL application. So I think this job is still running, so let's proceed with talking about dealing with schema changes in MySQL application. So schema changes in MySQL, in general, you can put in 4 categories. Online DDLs, so these are the DDLs that are not locking writes to the table. They have been introduced lately. Most of them have been introduced in 5.6. Not so online DDLs, which are basically the old type of chain or alters, which as of yet still require locks on the table. So the table is write locked. We have rolling schema upgrade approach. So we have, if we have master slaves, we can implement the change one slave at a time, going through the topology. And then we can use external online schema tools like online schema change, for example. So the problem with MySQL application is that lag is a serious factor and seriously limiting how we can execute the DDL. So the problem with the online DDLs is that they are online on the master. So basically, on the master, you can execute an alter, you can add an index, you can do whatever you want, and it will not lock the table, which is great. But the problem is when this alter this event is being replicated to the slaves, it will lock the replication thread. So basically, the replication will be locked for the duration of the DDL. And this is true even if you're using multi-threaded slave. So there is no workaround here, unfortunately. Therefore, it makes direct alters, online or not, doesn't matter, suitable only for small tables. So basically, if your application can allow some lag, you can work within those limits. If you this kind of limits your ability to the size of the tables on which you can execute the DDL.